In the chemistry laboratory, a common task we will face is that of separating the components of a mixture. Just like in nature, reactions in the lab produce mixtures of solids, liquids, and gases. In order to isolate a compound from a product mixture, some kind of separation technique is required, and the appropriate technique will depend on the phases and characteristics of the components we are trying to separate. Today we'll be looking at filtration. This is a fast and easy way to separate solids from liquids. The way a filter works in the lab is just like a coffee maker in your kitchen. You pour solid items into a filter and the liquids go through while the solids stay on top. Filters come in many different varieties, but today we'll be looking at the two main types of filtration used in general and organic chemistry labs. These are gravity filtration and vacuum filtration, and they are named after the specific mechanism used to move the liquid through the filter. Let's examine these techniques one at a time. With gravity filtration, we're using the gravitational force, as the name implies. We pour the mixture into the filter and let gravity do the work. This technique is commonly used when we want to remove impurities from a product, or when we want to remove a drying agent that has been added to a compound in the liquid phase, meaning a solid that coordinates to water molecules and removes them from solution. In either case, this means that it is specifically the liquid that is the target we want to isolate. For a gravity filtration setup, we'll need a ring stand, some clamps, a glass funnel, filter papers, and a clean flask or beaker to collect the filtered liquid. This liquid is called the filtrate. First, you'll need to fold the filter paper so that it can fit in the funnel, as the filter paper is what will separate the components of the mixture, since it has tiny pores that let liquids through, but not solids. There are a few methods we can use to fold the paper. What we certainly don't want is to leave an open hole in the filter, like this, because the mixture will go through unfiltered. The most common method for folding the filter paper is to start with the circle like this, then fold it in half, and then fold it in half again like this. Now comes the fun part. You open the outer layer and make a cone that will easily fit into the funnel. A more advanced way to fold the paper is called the fluted filter paper method. You can do this by folding the paper this way into 8 sections and then putting it into the funnel like this. This maximizes the surface tension of the filter and makes the liquid go through much faster. For most students in a general chemistry laboratory course, the first method will be just fine. After folding the filter paper, you're now ready to assemble the filtration setup. Add the filter paper to the funnel. If you find that it does not stay in place, wetting it slightly with the same solvent that is present in the mixture that is to be filtered will cause it to adhere to the glass. This is usually water or some organic solvent. You'll need to wet the paper evenly using a squirt bottle, and be careful not to leave any dry spots or bubbles. With the setup done and our mixture handy, we are now ready to start the filtration. We'll begin by making sure our solution is well mixed and ready to go. After giving it a swirl to generate a suspension, you'll gently pour it into the filter setup. You should start to see the liquid move through the filter and slowly drop into the receiving flask. If at any point you see some powder or solid in the flask, your filter is perforated or incorrectly folded, and you will have to start again with a new receiving flask. When introducing the mixture to the funnel, always pour slowly and wait for the level of the liquid to go down before you pour some more. Do not pour so much that the level approaches the top of the filter. If the filter overflows, some of the mixture will reach the receiving flask unfiltered. Continue slowly and keep pouring the mixture until you're done. Sometimes you'll have some powder left at the bottom or on the sides of the original flask. You can wash it with the appropriate solvent and pour that into the flask like this. This is an important step as you don't want to lose any of your product. Once the dropping stops, the filtration is complete and you have successfully separated your liquid from the solid. Gravity filtration is a great way to separate small mixtures that go through the filter quickly, but if you have a large volume of the mixture, it can be very time-consuming. This is one of the situations where vacuum filtration becomes desirable. Vacuum filtration is just like gravity filtration, except that in addition to using gravity to drive the separation, we utilize a vacuum pump as well. A vacuum pump is used to drive the air out of the flask and create a pressure differential between the inside and outside of the flask. This causes atmospheric pressure to push the liquid through the filter much more quickly. For vacuum filtration, the setup will be slightly different. We will need a special flask called a Buchner flask. This has a line out that will be attached to the vacuum. We'll also need a rubber hose and a vacuum line. Many chemistry laboratories have vacuum lines built into the workstations, but a standalone vacuum pump can also be used. And we certainly will also need a Buchner funnel. This is attached to a rubber stopper so that it can make a tight seal to maintain vacuum. Again, we will need a ring stand and clamp. And finally, we'll need some filter paper, which is of a size that fits into our Buchner funnel, making sure to cover all of the holes, but not quite touching the perimeter, so that it can lay perfectly flat on the bottom of the funnel. If your paper is too big, you can cut it using scissors until it is an appropriate size. Again, make sure you don't leave any of these holes exposed, or your unfiltered mixture will go through and contaminate the filtrate. To assemble the setup, connect your Buchner flask to the ring stand and clamp. Be sure to clamp it tightly or it may fall over during the filtration. Then attach your vacuum line to the flask. Add your funnel to the flask and make sure that it creates a tight seal, otherwise the vacuum won't work. And finally, add your filter paper and then wet it with the appropriate solvent. First, turn on the vacuum slowly and make sure it's working. You'll know that it's working when you see the paper stick tightly to the funnel. If it's not working, that means there is a leak in your system, so make sure you check your flask setup and your vacuum line connection. If the solvent is highly volatile, it may dry out quickly once the vacuum is on, so just apply more solvent. Next, you pour your mixture into the funnel and watch it go through. It should be much quicker than gravity filtration. If it's too slow, turn up the vacuum to make the filtration go faster. Make sure you don't turn it up too high, as this can rip your filter paper and all the solid will go through. If that happens, or if you see any solid in your filtrate for any other reason, you can just get a new clean Buchner flask, new filter paper, and repeat the filtration. Now, just like with gravity filtration, you keep pouring your solution into the funnel until you're done. Make sure the funnel doesn't overflow, and make sure your filter paper doesn't get dislodged from the pores, as the mixture will go through if that happens. Additionally, you must be aware of the level of the filtrate accumulating in the Buchner flask. We do not want this to approach the side arm, or it will get sucked into the vacuum. If it gets too high, turn off the vacuum, transfer the filtrate into some other flask, reconnect the filtration setup, and resume. Your solid should now be depositing nicely on top of your filter paper like this. After you're done, let the vacuum line run longer to dry the product some more. In the end, you'll be left with any solids on top of your filter paper and any liquid in your Buchner flask. In some experiments, our desired product will be the solid, and in others it will be the liquid filtrate. Sometimes you may need both. But when the product is a solid, vacuum filtration is often specifically desirable over gravity filtration, as the vacuum will help the solid dry very quickly, and it can be very easily scraped off with a spatula for further drying and analysis. So that's how you perform gravity filtration and vacuum filtration. We'll be using these techniques many more times in this series, especially during experiments where we synthesize something. With any synthesis, we will always have to separate the target compound from a mixture of unreacted starting material, side products, and solvent in order to obtain a pure product.